Madam, here is your question. So this is how I'm solving your question now. That was question 9. Consider the reaction. So that is the ammonia gas plus copper 2 oxide to give us nitrogen gas plus copper metal plus water in gaseous state. Okay, so the equation there is even balanced here. So if we see these numbers, it means the equation is balanced for you. Now the information which is here is here 18.1 gram of ammonia, which is NH3, is reacting with 90.4 grams of copper 2 oxide. Full stop. Continuation. Predict the limiting reactant and mass of nitrogen gas formed. Okay, so we need to predict the limiting reactant here and the mass of this that was produced. Okay, so what is the limiting reactant? I will not lie. So if you need the definition for the limiting reactant, you can just get it from the video, from the voice note. Okay, so what is the limiting reactant here? By the way, what's the definition of a limiting reactant? So the limiting reactant, it is a reactant which is used up in a chemical reaction and determines how much of the products will be formed. Okay, so it's a reactant which finishes up first in a chemical reaction. So here we have two reactants. We have ammonia and copper 2 oxide. So when they say a limiting reactant, they are saying which one will be used up in the chemical reaction or which one will finish first in a chemical reaction. So when one reactant finishes, then the reaction will be over. Okay, so this is more like grade 12 work. Now the information that they have given us is this. Here 18.1 gram of ammonia reacting with 90.4 gram of copper 2 oxide. Predict the limiting reactant. So how do we predict the limiting reactant? It is by calculating the number of moles of both reactants. So we calculate the number of moles of this. Okay, thank you. We calculate the number of moles of this. We also calculate the number of moles of this. So as we calculate the number of moles here, the one between these two, which is going to have less number of moles, will be the limiting reactant. So which formula do we use to calculate the number of moles? Okay, so we are calculating first for this. So here I'll say NH3. So what we are calculating for first, which formula do we use to calculate for the number of moles? We use the formula number of moles is equal to mass. So this is mass over molar mass. This is the formula that I even saw there in your in the document that you sent to me. Okay, so we are saying mass over molar mass. So where do we get the molar mass? The molar mass, we add the atomic masses of the elements that are in a compound. So in this case, we are adding the atomic masses of ammonia. So let's get the molar mass of ammonia. So molar mass of NH3, which is ammonia. So nitrogen, it is from the periodic table that you gave me, it is 14.00674 plus, then we have nitrogen. Okay, so I mean hydrogen. So hydrogen, again, from the periodic table that you gave me, it is 1.00794, but we have 3 atoms of hydrogen, so we need to multiply that number with 3. So it is 3 times 1.00794. Okay, so the final answer will be, we are going to have 14.00674 plus then what we get from there. So let me punch on my calculator. So 3 times 1.00794, it's giving me 3 0.02384. Then that number we add 14.00674, so plus 14.00674, so 674. Then it will give us 17.03056. Okay, so this is the molar mass of ammonia, so we say grams per mole. So molar mass is measured in grams per mole. Those are the SI units of molar mass. Okay, so now we get back to our formula where we are saying number of moles is equal to mass over molar mass. Okay, so what is mass? The mass here, we are saying it is excuse me. The mass, we said from the question it is 18.1 grams. That is for ammonia over. Then the molar mass, the one we have calculated here, which is 17.03056 grams per mole. So grams and grams, they will cancel there. Therefore, number of moles will be equal to, so we are dividing 18.1 divide 17.03056. Okay, so 18 from the calculator here, I'll just say 18.1 divide my answer there, which is 17.03056. Okay, so let's say divide my answer there. So I'm getting 1.06279531 moles. So those are the number of moles of NH3 or ammonia. Okay, next we need to calculate the number of moles of copper 2 oxide. So we write here copper 2 oxide. Okay, we are also using the same formula because we have been given the mass. So whenever we have been given mass, we want to calculate for the number of moles. The formula that we use is number of moles is equal to mass over molar mass. So there are a lot of formulas for the number of moles, but it all goes within the quantity that they have given you. So the quantity here, it is mass. No wonder we are using this formula for mass over molar mass. Okay, so also here we need to get the molar mass of copper 2 oxide. Okay, so copper from the periodic table that you gave me, it is 63.546. Okay, then oxygen, it is 15.9994. So if we add these two numbers there, we are saying for copper 63, .546 plus 15.9994. We add those numbers there, we are getting 79 points. So the final answer here, when we add them, I'm getting 79.5454 grams per mole, which is the SI unit for molar mass. Okay, so I'll come back to my formula, then I'll say the mass I was given 90.4 grams over the molar mass I have 79.54 grams per mole. Okay, so grams and grams will cancel there. For number of moles is equal to, now I'm saying 90.1, I mean 90.4 divide my answer there. Okay, so I'm getting 1.136457922 moles. Okay, so from here, if I compare the ratios here, I mean if I compare the number of moles I can see that this number of moles is less than this number of moles. So I can put a statement here. I can say comparing the moles, the number or the, comparing the calculated number of moles, comma, the number of moles of ammonia, which is NH3, is less than the number of moles of copper 2 oxide. Full stop. Thus, which is therefore, okay, thus NH3 is a limiting reactant. They also ask about the excess, the reactant in excess. So in this case, if NH3 ammonia is the limiting reactant, then copper 2 oxide will be the reactant in excess. So this is a comma. So this copper 2 oxide is the reactant in excess. Okay, now the next question. We have determined the limiting reactant by the number of moles. Wow, because this number of moles is less than this number of moles. As you can see there, it is 1.06, but here it is 1.1. So this is less than this. No wonder this is less than this. No wonder the number of moles of ammonia. No wonder ammonia is the limiting reactant. Okay, next question. We are saying in the same question they are said and, so we predict the limiting reactant and mass of nitrogen gas formed. So we need the mass of nitrogen gas formed. So remember the definition of a limiting reactant. I said it is the reactant which is used up first in a chemical reaction and determines how much of the products will be produced or formed. So just because of that, we use the limiting reactant to compare the mole ratios with what will be produced to the product side. So if we want, we can use the number of moles. We compare the mole ratios with nitrogen, so that we calculate also the number of moles of nitrogen. Then we calculate its mass. That will even consume much of our time. If you want it in that way, I can make a video for that, because in not all questions we can go with the shortest method. Okay, so the shortest method here is, we know that ammonia is the limiting reactant, so we write the balanced chemical equation. We know it is 2NH3 plus 3CuO, which is copper 2 oxide, to give us nitrogen gas. So nitrogen gas, to give us nitrogen gas. So this is the chemical equation: nitrogen gas plus copper metal plus H2O, which is water in gaseous state. Okay. Now they are asking how much of N2, which is nitrogen gas, is formed. So we know this is the limiting reactant. So we are going to compare the ratios of NH3 to nitrogen gas. So from the balanced chemical equation there, we know there is a 2 there. But as we compare the ratios there, usually to use this formula, you use a balanced chemical equation. So what do? We have the mass of ammonia, which is 18.1 grams, and then they are looking for the mass of NH2, which was formed. So We don't know. Why are we using ammonia? Why are we not using copper 2 oxide? We are using ammonia because it is the limiting reactant. Okay, so we have the mass of ammonia, but we don't have the mass of nitrogen gas. Okay, what about the molar mass of ammonia? Okay, the molar mass of ammonia, we calculated it is here. Okay, but it is here, which is 0.03056 grams per mole. But from the Barnes chemical equation for ammonia here, we have A2. So meaning that molar mass for ammonia, we are going to multiply it with 2 here. So for this method here, we need to use a balanced chemical equation. So 2, we are saying 2 times that is 17.0, so which is this one, the molar mass of ammonia. Because there is a 2 there, no wonder we are multiplying it with 2 now. So 2 times 17.03056 is giving us 34.0. So it's giving 34.06112 grams per mole. And then this side also, we find the molar mass of nitrogen gas. This side, we also find the molar mass of nitrogen gas. After finding the molar mass of ammonia with a 2 there, if you want, you can even put it here to show that no wonder we are multiplying that 17.03056 with these 2. Okay, this side nitrogen. So from the periodic table, nitrogen is in 14.00674. So now we are multiplying 14.00674. That is on the periodic table for nitrogen. We are multiplying with a 2. Why a 2? Because it is N2 here. Even in the balanced chemical equation, it is N2. So times 2. We are getting 28.0134 grams per mole. Okay, then we cross multiply. So we are going to have 34.06112 grams per mole times M there. So it will be 34.06112 grams per mole. Then M, meaning mass. Okay, which is equal to also 18.1 grams times what is there. So this answer that I have here, this answer times 18.1 grams, which is the answer on the calculator there. Okay, so times 18.1, okay, is equal to, it has given me 507.043988. So there is this grams and there is that grams there. So they cancel, meaning you just have the mole as the units there. Or if you want, you can say, since we have grams per mole, you say grams per mole, then dot grams, which is in this side. Okay, then we divide through, since we are looking for mass, we divide through by 34.06112. Then the units grams per mole, they are going even this side 34.06112 grams per mole. Okay, yes. Okay, so this and this will cancel. So mass is equal to then 507.043988 divide 34.06112. So that answer on the calculator divide 34.06112. Okay, answer I'm getting 14.88629816. So what will be the units? Meaning grams per mole, they will cancel. So the units will be grams. Of course, they are looking for the mass of nitrogen gas that will be produced. So that is how we go about this question. Usually questions that involve stoichiometry for solving, you can involve me, stoichiometry for solving, except there are certain things that I'm not able to understand there, especially for accuracy, and there are a lot of things there. Accuracy, there's also precision, accuracy. Those terms, I may not be familiar with them. My field, they were not in my field, but with regards to stoichiometric calculations, I can help you. Yeah, there I can help you. The number of moles, all stoichiometric calculations, I'm very familiar with them. Okay, thank you.